Those little guys right there are going to be 24 and 24. All right, so we have to look out for that. Then it says find the radius. So remember, we can write our radius anywhere, but it really wouldn't make sense if I wrote it out here, because that is not even involved in my numbers whatsoever. So whenever they give you a radius and you have a chord, most of the time you're going to connect the chord with the radius on either side to create that right triangle. Now I have a right triangle with lengths 24 and 10, and we just need to find the radius. Well, that's just going to be 24 squared plus 10 squared equals r squared. We do some work, dot, 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 and we come up with r equals 26? 26? 26. 26 centimeters. Whoa, gotta get that guy in there. Questions on anything I did? So if you knew how to do this, you know how to do a question that's on the test. All right, maybe different numbers, but very, very similar. Okay? So always remember, before a test, study your bell work. You'll find you get 4 to 5. And remember that last test we took where like a whole bunch of people missed a couple problems, and then I pointed out that they were bell work questions, and those were the most missed by people. So sometimes I pick really hard questions, put them in bell work. So make sure you pay attention, you try them, and you study them. All right, let's go to questions on the homework. Questions on the homework. Let's hope I got that guy up. I do not, cannot, should not. Yeah, we're good. David.
Number 7.
Number 7. Where is number 7? All right, the big thing about number 7 is to recognize which ones are congruent. Well, let's go ahead and label. So we have PA is congruent to AO. So we'll write down what they tell me. PA is congruent to AO. I'm just going to stop right here. What does PA have to do with PC? They're also congruent. They're congruent because of that tangent property we had, where if it's tangent and they intersect, they must be congruent. So PA must be congruent to PC. So let's go ahead and mark that right off the bat. What about AO and OR? Would that follow the same rule? Are they tangent? Do they intersect? Yeah, so these two things are also congruent. So just from that very first statement, I know all 4 of those are congruent. Then we have CT equals RS. So CT equals RS. Well, if CT, what does that have to do with DT? I can't move my hand that way. They're congruent as well. Thank you. They're congruent as well. And RS is congruent to DS. And I think, David, as soon as you put the numbers in, because OR equals 13, and ST equals 12, or we got ST, S to T equals 12. So if ST equals 12, what does DS equal, David? 6, yep. And you can get the rest, right?
Yeah.
Okay. So just make sure, remember how like half the time I do all of this work before I even plug in numbers? It's always a good idea. Do as much as you can from the given information, and then look at the question. And then look at the numbers. Yeah, Brent.
To do that thing with number 8, right?
Yeah, basically it's the same thing on number 8. I feel like there was a trick in number 8. So let's just look at number 8. So number 8 is, well, I'm going to mark all the things that I know are congruent. So I know this guy is congruent to that guy. I know this guy is congruent to that guy. I know this guy is congruent to that guy. I know this guy is congruent to that guy. And it tells me that WO equals 14. So WO equals 14. SW equals 11. Well, this isn't helping me much. But they do tell me that ST equals 5. So if that's 5, that gives me 6. That makes this 6, which makes, so you should be able to go around then from there. As long as you had them marked correctly. All right, because 6, that 8, 8, and we can just go around that way. Okay? All right, other questions from the homework? Mazin?
I have a question on like one step of 17.
On 17. Okay.
So like you draw the triangle and everything.
Mm-hmm.
Side of it. I'm just on your answer key you had two numbers. I don't know how you got them.
Which two numbers?
4 and 4 on the top
The 4 and 4 on top
of the triangle.
of the triangle. Oh, okay. The 4 and 4 are top because those have to be congruent. Those have to be congruent.
Because they're tangent.
Mm-hmm.
But where are you getting 4 from?
I'm getting 4 from the other because nothing else would work there. Because, let's look real quick. Let me take a picture of mine. Nope, I don't want to put it there. I don't want to put it there. I want to go to a brand new one. I want to go to a brand new one. Okay, so A, we know these are tangents, these create right angles, right? And this is 4, this is 4. So because these are right, these are right,
Oh, it makes a square.
it makes a square. It has to make a square. It has to make a square because we got 4, 4. And since those are right angles, which makes a square, which makes the top one right and the bottom one right as well. Okay? Yeah, I'm not gonna put anything like this on the test. Like I said, it was a bonus question. It was good. It's good thought. I mean, you have to kind
It was
of.
the bonus. Okay, I was very.
Yeah, I said 17 was our bonus one. Yep, I did say the bonus one in this one, right?
Yeah.
The number. Okay. All right, Brian.
16.
16. So the big thing about 16. So we have SR is tangent to PO, so that I automatically know this is a right angle. I also know that this is a right angle. QT equals 6. TR equals 8. And P to R. P to R equals 30. So that equals 30. So what you're going to do is you're going to use the fact that we know 6 and 8. That's going to get you QR, right? So you probably got QR. And is what?
10.
10? Yeah, it's 10. So you would have got that 10, which would give you PQ, right? Which equaled 20.
I didn't really know where to go from there.
Now we have to recognize that, do you see this big triangle
Yeah.
and this little triangle? Those two things are similar triangles. Okay, so when I compare 10 to this full length of 30,
It would be 1.
it would be, yep, 1 to 3, which would mean we could do 1 to 3. Small to big would equal small triangle to big triangle, so that would be 6 to this missing side. Let's call it X. Does that make sense? And then you get that side, and you can either keep using that property, or you can just use the Pythagorean theorem to get this full length as well.
And is it 20, 18, 16?
20, 18, and 16, yep. Yep. Did you just get the X right now?
I couldn't figure out the other two.
Right, yeah. But does that make sense then? Okay, good. Okay, other questions? Let's go around. What was the number? 13. 13. Okay, 13, we're going to use similar triangles. Again, it says that BD is common tangent to A. What is A I'm missing a whole bunch of information because I'm zoomed in. There we go. AB equals 36. Wow, if I didn't know that, we'd been in trouble. I was so far zoomed in, I just saw half the question. All right, so we have not 36 degrees. And then we have CD equaling 24. And then we have this total length here from B to D equaling 80. Well, I know can you picture these two triangles here? Well, I know I'm going to do something with both those triangles, so I'm going to label B to E X, because I don't know what that whole distance is, which would make E to D 80 minus X. Then I'm going to recognize an important fact, that lines that are tangent, that are connected to the distance of the ratio, well, that's 90 degrees. So this guy would be 90 degrees. Well, this angle is the same. These two angles are the same. These two angles are the same. If two triangles share the same two angles, we can use that angle-angle property of similarity to say this big triangle here is similar to this triangle here. So now using that, I'm going to say, well, I can come up with a ratio, 24 over 36. You could simplify. I'm just going to leave it as 24 over 6 for right now. Is going to equal, so small triangle to big triangle. Small triangle would be 80 minus X. To big triangle, which would be the X that I said. And when you do your cross multiplication, you're going to be able to solve for X. You're going to be able to plug it in, get that whole length, and you can get any other length you want to from there. That make sense? Yeah, it's a similar triangle. Hannah? 14? Why aren't you next to it? 14, 14, 14, 14. Okay, so the big thing we have to keep track of is this distance is 3, this distance is 3. That's what these little lines mean. So if this distance here is 3, what is S to A? 3 as well. The big trick on this one is to recognize I can't do much with this except for I know that this is a right angle. This is a right angle. I also know that this is 11 because it's a radius. But there's not much else you can do unless you draw something here. And what I'm going to draw is a rectangle. And if I draw a rectangle that has nothing but right angles, that's going to make this 3. And that's going to make this 8. Well, if I know this little distance is 8, and this distance is 11 plus 6, which is 17, I have a right triangle. I just need to find that side, which would give me that side.
Okay.
Does that make sense? You know how to do it from there? Okay. Other questions? Nope, we answered all the ones that people had. Okay, good, good. Did we all find the answer key online? All right? Okay. All right, so let's go ahead and do today's lesson, which is going to be quick. And really just boils down to one really big one and a couple small offshoots of that one big property. And we already know this property, actually, or this theorem, or however we want to picture it. It says, if an angle is inscribed in a circle, then the measure of the angle equals blank the measure of the intercepted arc. So remember, if you have a central angle, those two things are equal. If I had a central angle, this would be 106. When I go to inscribed angle, what did I say happened? It was a while ago and we didn't really use the fact. But what did the measure equal? Yeah, it was half. It was half, and you can remember that because your central angle has to be bigger than your inscribed angle, because if you look at my hand to point to those two things, this has to be closer, that has to be wider. All right, so this one equals 106. This one equals half of 106. And half of 106, well, let's go ahead and write in 1/2. So that's half. Half of 106 is going to be 53, I'm pretty sure. But just remember, don't forget about the fact that a central angle, if I drew a central angle, that central angle would equal 106. So central, exactly the same as the arc is created. Inscribed, half. Half that length. And this is the big guy that we're going to use for almost all of these other ones, because all the other ones are just offshoots of this one. All right, so it says if two inscribed angles of a circle intersect the same arc, then the angles are, well, let's figure it out. If this inscribed angle is 27, what is the arc it creates? Not 27, what should it be? 54. Someone say 58. So it should be 54 degrees. And if we go back, well, if that's 54 degrees, what is B? Same arc, inscribed angle.
22, 27, 7.
27, yeah, 27. So B is going to be 27 as well. So if two inscribed arcs share the same, or two inscribed angles share the same arc, they are going to be congruent. And if we notice, these create the exact same arc, so that makes them congruent. They are congruent. So even if you didn't memorize this fact, this theorem, you could just know this one and get there. Because if I gave you find B, you would just go, okay, I'll go here, come back. Oh, they're the same. Got it. Didn't even memorize that theorem. That one's based on the first one. This next one's based upon the first one too. An angle inscribed in a semicircle is something. Well, let's look at this. So I have a diameter, right? So an angle inscribed in a semicircle, basically going to our diameter. What is half the degrees of a circle?
180.
180. So this is 180 degrees. Well, if that's 180 degrees, that looks like 1800. Let's make that a degree. If that's 180 degrees, what is my inscribed angle that creates that angle going to be? David? 90. And that's always going to work. So an angle inscribed in a semicircle is a right angle. But like I said, if you do that first property, you can get this one. So in your homework, be on the lookout for diameters. All right, creating 180 degree arcs and changing your particular angle. Okay, continuing on. So the angle formed by a chord and a tangent. So if I have a chord and I have a tangent, it doesn't make 90 degrees. The only way it's 90 degrees if it's a chord going to a radius. So a radius, I mean not a chord and a radius, a tangent and a radius. That equals 90 degrees. This does not equal 90 degrees because it's not going through the center, so it's going to be a little different. So the angle formed by a chord and a tangent that intersect on a circle is the measure of the intercepted arc. So surprisingly enough, this is still considered an inscribed angle. It doesn't look like it, but it really is. Because if you picture an inscribed arc, it just connects here. And if we keep moving that point closer and closer and closer and they equal, it's going to create this line. So this acts just like an inscribed angle in the fact that this angle, that 196, that's what we're talking about, is created by it. So let me highlight that. So I'm talking about this arc right here. That's what's created by that tangent and that chord. That works just like an inscribed angle in the fact that that C is going to be half. It's going to be half of that other thing. So it's going to be 98 degrees. So the angle formed by a chord and a tangent that intersect on a circle is half the measure of the intercepted arc. This one isn't used all that often. All right? So just kind of remember it, study it, because it's not used that much, but it can show up. It is, you still need to know it. All right? The big thing you're looking out for are tangent and is it connected to a chord. All right, maybe I'll put more on this one real quick. I'm just going to put a little addendum to this that we know this is a tangent line, so generally in a drawing it's going to look like that. Right? Because it can go on and just hit the circle once. That's what makes it a tangent. All right, angles formed by parallel chords are, and what I'm talking about is, well, let's look at the picture. If this is 78 and these two lines are parallel in the circle, just looking at it, what does D equal? What was that?
Equal.
Yeah, they're going to be equal. D is going to be, it has to be. We create a straight line. This has to be the same thing. But along with D equaling 78 degrees, it creates the same angles as well. So if I created a center angle like that, that would be 78 degrees. And everything would basically be 78 degrees. Just like if I had an inscribed, that would be half. And the inscribed the other way would be half. That's 78. So angles formed by parallel chords are congruent. So when you're doing problems with parallel chords, think about all the angles you can create that are also congruent, along with the fact that these two are congruent. Our central angles would be congruent. Our inscribed angles would be congruent. So it creates a lot of congruencies. All right, the very last one we're going to cover is what happens if I have a quadrilateral inscribed in a circle. Then its opposite angles are, and we're just going to fill it in, they are going to be supplementary. So they're going to be supplementary. So we have supplementary angles, but that's only if they're inscribed. So that means if, say, F is 70 degrees, we'd look at that opposite angle and say, well, they need to be supplementary, so that's going to make G 110 degrees. All right, we're going to do one homework together. We're going to do one homework together, and I picked number 5. So F should be easy because I have an inscribed quadrilateral. So the angle opposite needs to be supplementary. So what does F equal?
90.
It has to equal 90, yeah. Even though it doesn't quite, well, I guess it looks like it. We're going to know F equals 90 degrees. Okay, now I need to get G. Well, if I knew this entire arc from here to here and I subtracted away 110 from it, I would know what G is. Well, it turns out we can get this measure. Because this measure is created by this angle. So my goal right now is to, let me highlight it really quick, let's highlight it in red. I want to get the measure of this angle here because that's going to give me the measure of the arc. Well, if we look at, we got 74 across the way, so that's going to mean this angle actually equals what? If that's 74, right? 106 degrees. Now, if this is 106 degrees, that would make that total angle that created it, so this total angle here, that total angle is going to be twice 106, which is going to be 212. So that whole arc is going to be 212. Well, to get my G, I just take 212, subtract 10 from it, or 110 from it, I'm going to see that G equals 102 degrees. Okay, does that all make sense? All right, then go ahead and get started. Answer keys are over here.